Hi everybody, this is Gigi from Kauai Community College. In this video, I will be talking about volume by slicing. This is the second video in this topic, so please watch my first one before this. We are going into particular examples in this video. Alright, so find the volume of the solid generated by revolving the region bounded by the y-axis. Okay, by the y-axis, the line. So let me go ahead and draw the y-axis right here. Okay, the line 5 minus x. And I'm gonna go ahead and give the x-axis on here so that I can draw the line y equals x. Let's see. Nope. We want to go ahead and erase this right here, and we want to go ahead and erase this right here, and we want to go ahead and draw the line, the x-axis right here. Okay, and then now what we want to do is we want to draw the line y equals 5 minus x, and the line 5 equals minus x is going to start at 5, and it goes downward slope 1, 2, 3, 4, 5, and it would downward slope and it will look like that. That's the line. Okay, and we can extend this line a little bit longer if we need to, but I don't think we do. And then we need the line y equals 2. That would be a horizontal line, y equals 2 right here. That would be this line right here, y equals 2. Okay, so draw that line. Okay, and we are looking at the regions bounded by the red, the blue, and the y-axis, and we are going to revolve it. Okay, we are going to revolve it about the line y equals 2. Okay, so here is y equals 5 minus x. Okay, and revolve it around the line y equals 2. So what you'll need is to go ahead and visualize that line. And so that line would go like so, from here to here, like that. And that would be a 3-dimensional shape, right? So that would look like that. And this part right here, then you will revolve it around the line y equals 2, so it makes this cone shape right there. And we want to find the area of that cone shape. So slicing it this way, right? And then think about the boundaries. So this point right here, as you can see, is 3, right? And we start at 0. Okay, and I'm gonna go ahead and take those lines away because I don't really like writing on the lines. So I'm gonna get a blank paper here. Okay, and here we go. We would say now the volume is going to equal to the integral from a to b, which would be 0 to 3, right, of the area dx. Now the question is, what is that area? Okay, so let's take a look. The cross section here is going to be looking like this, like a circle, right? And the thickness is, again, that's delta x, and that's why we have that dx right there. Okay, now the radius, you'll need the radius right here, right? So where does the radius come from here? It comes from here to there, right? So the radius in this case is 5 minus x minus 2. because it goes from here, drop down to here, right? So this whole entire length from here to the x-axis is 5 minus x, right? But then you are only taking that top part, so you have to subtract out 2. Okay, so red minus blue, that's what it is. Then we would say the area of this area that is represented right there is going to be pi r square, and 5 minus x minus 2 is 3 minus x square dx, and that would be taking the integral from 0 to 3, and that is your volume. Okay, clean that up. So you have integral from 0 to 3. I can put the pi outside, square that. I get 9 minus 6x plus x squared dx. Okay, now take the integral. I would have pi on the outside. This would be 9x minus 6x squared divided by 2. So I'm going to go ahead and write 3x squared plus x to the third divided by 3. And evaluating that from 0 to 3, because those are your boundary. Okay, plugging in the volume. So volume is going to equal to 9 times 3 is 27, minus 3 squared times 3 is 27, plus 3 squared, 27, divided by 3 is 9, and then minus, when you plug in 0, everything is 0 right there, so the volume would be 9, and this would be cubic units, because we're talking about volume, right? Okay, now that is how you do it, by slicing using calculus. But you know what? Think about this for a second. This is a cone, right? So you're looking at this shape like this, a cone that looks like that, right? And the height is from here to there. That's h, and that's this height right here. So h would be 3 units, and the radius of that cone is right here, and that is 3 units as well, right? So then if you really think about it, what's the area of a cone from your geometry class? What's the volume of that cone from geometry? A cone is a third of a cylinder, so it's 1/3 pi r square h. Okay, pi r square h. So then plugging in 3 for r and plugging in 3 for h, volume is equal to 1/3 times 3 squared times 3. 3 cancel with 3. That gives you 9, and that is the same volume of this one. So then you will be asking me, what the heck? Why didn't we just use geometry? Well, you can use geometry if you see it, but now you know how to do it using calculus. All right. So anyways, be on alert, as far as what's the easiest way, what's the most efficient way. Do you always have to do calculus? No. In this picture, you should be able to recognize that's a cone, 1/3 pi r square h, and you would have gotten the same answer. Okay, that is it for this problem.